So in motion, we are going to divide motion into three parts. This chapter that we're going to talk about would be 1D, and the second chapter in the next lesson would going to be 2D, and last one, which we're not going to take in physics 1, which is 3D. What is D right there? D means dimensional. So in the first one, we have one dimensional motion. What does that means? That means that the object that we have is moving in x-axis or in y-axis. So it's moving horizontally here in x-axis, or it moving in y-axis. So someone is walking, he is moving in the x-axis. A ball is throwing from a cliff, so that means it's moving in the y-axis. What is 2D motion? 2D motion would be x and y together. So someone kicks a ball, it's gonna move up and forward in the same exact time. So instead of or y, it would be and y. Both of them are having the same situation in the exact same time. What about 3D? 3D is our life. Anything that you can have in your life right now would be a 3D, which is the phone that you have, your laptop, the cup on your desk, whatever. This is three-dimensional, which is consisting of x, y, and z. Now we are going to go over the key quantities in one-dimensional motion. First one is displacement. The unit of displacement is meter. Second one is velocity. I don't remember the unit of velocity. How we can get this? We can get it from the formula. What is the formula regarding velocity? Velocity is equals to displacement divided by time it took to move this from one point to the other. So what is the unit of displacement? Displacement is meters. What is the unit of time? Time, of course, is seconds regarding the SI units. So the final unit of velocity would be meters per seconds. What about the acceleration? Oh, what is the formula regarding acceleration? Acceleration is a change in velocity divided by change in time. So let's figure out the unit right there. Velocity, as we said, is meters per seconds. And what about time? Time is also seconds. So meter per second will lead to meters per second squared. Here's it, the unit regarding acceleration. And last one, the time, the unit of time is seconds. Okay, in this part we are going to talk about constant velocity. If we have an object moving with a constant velocity, that means that the velocity is not changing. So 5 meters per second for the whole time, 10 meters per second. It's never changing. It's always regarding its motion, it would be 5 meters per second, 5 meters per second. So that means the acceleration right there is equals to 0. No acceleration in this movement. But for the accelerated object, so 5 in the first 1 second, and after that 10, and after that 20, as you can see, there is a change in the velocity, even if it's moving from 20 to 0. There is a change in the velocity right there. So 100% acceleration right now is not equals to 0. We have a value for acceleration. Okay, right now we're going to talk about graphs. First one, we're going to talk about position versus time graph, which is very important. A lot of questions in the exam would be regarding this one. As you can see, this one, the position of the car or the human is constant while the time is passing. So that means this object is at rest. It's not moving right now. But this one, on the second one, the object is changing its position regarding time. So here we have a change in the position, but with a uniform speed. So this one would be uniform speed. Last one, as you can see, a diagonal shape or a parabolic shape. So non-uniform speed regarding the change in the position. Let's move to the second graph that we have. We are going to have velocity versus time graph. For the first one, we are going to see that the object right now is having a straight line, but that not mean that the object is at rest. No, it's moving, let's say, with 10. So while time is passing, it's having 10 meters per second. So that means that it's having constant velocity. This one, the velocity is changing 10, 20, 30, 50, whatever we are going to have, but would be with the same value. So this one would going to be constant acceleration. As you can see, this one, 5, 20, 30. So no constant movement right there. So this one is increasing acceleration. So this is those for the graphs that we have that would be asking in the exam. And regarding the position versus time, you're gonna have the slope in this one. In the position versus time, slope is equals to the velocity. And in the velocity versus time graph, the slope is equals to the acceleration. Last part in our lesson for today for the kinematic equations that we are gonna use. First of all, you need to make sure that while you are using kinematics equations, acceleration is not constant. So never use kinematics equations if acceleration is not constant. Okay, this is the first rule that we need to say. And the next part, we're going to talk about the equation that we have, v final velocity. So this one is final velocity, never forget, equals to initial velocity, here's it, plus acceleration multiplied by time. Change in displacement. This one can be x or it can be y, depending on the movement that we have. So for example, if I'm talking about a ball thrown from a cliff, so this one would be delta y equals 2. If I'm saying that a car is moving from point A to point B, so that means that delta x that we are going to solve regarding it. So delta x is equals to initial velocity multiplied by time plus half acceleration t squared. Delta x is equals to half vi plus vf multiplied by t. And the last one, v final squared equals to v initial squared plus 2a delta x. Very important note, last one is the only one that don't have time on it. So if you have a question without time right there, so directly go to the last formula that we are gonna have. In our next lesson, we are gonna talk about the two-dimensional motion.